Welcome to a lesson with Dr. Powell. Let's look at another type of sequence that arises, sequence pattern. Suppose we have something like 3, 6, 12, 24, 48, 96, and so forth. What are we doing? Every time we go over 1, we multiply by 2. Well, this looks a lot like what happens when we have an exponential equation, like BMX. So in contrast to what we have for y equals mx plus b, these are linear functions. These guys are exponentials, where we have a multiplication slope. Do you remember how we talked about that? We're multiplying by 2 every time we go over 1. So we have the same thing happening here, but we're just going to restrict our domain to be whole numbers. So it works the same way, and we can use the same idea to come up with formulas. So here, remember what b is. It's the y-intercept. This is position 1, 2, 3, 4, 5, 6, and so on. If we wanted to get b, which is the y-intercept, we'd have to go to position 0. Go backwards. That's 3/2. Okay, so our formula would be a sub n in place of y, and b as the y-intercept would be right here, 3/2. Then times the multiplication slope of 2. Now instead of x, we use n. There's our formula. Very nice. Now, oftentimes in the book and other places, people write this down instead. A sub n is equal to 3 times 2 to the n minus 1. Why do you think they would do that? Well, let's look at this for a second. We can rewrite this as 3 times 2 to the n over 2, right? This 2 just goes down there to the 1. What happens with exponents here with the same base? They subtract. So we get 3 times 2 to the n minus 1. So these formulas are the same. But why would they like this one? That's because, see this 3? How do we get it? This 3 is 3/2 times 2. Wait a minute, timesing 2 is the key that moves us from one term to the next. That means that this guy is simply just a sub 1. So we could just plop down a sub 1 right here, have times 2 to the n minus 1. The trade-off is that the exponent is n minus 1 instead of n. So we have two different ways of writing this, and perhaps many more. We could write a sub n is equal to a sub 0, the y-intercept, multiplied by the multiplication slope, which in this case is 2, raised to the n. Or we could have written 2 to the n, or a sub n is equal to a sub 1 times 2 to the n minus 1. And just for kicks, think about this. If we were to pull one of these 2's away, so this is n2's multiplied together. If we took one away and put it with the a sub 0, 2 a sub 0 times 2 to the n minus 1, this guy is just a1, right? So they really are the same. Okay, so this is just a little example, and we'll be looking at more. Thanks for watching.